Hello, today we're going to be looking at dilations. A dilation is a type of transformation that changes the size of the figure but not usually the shape. So remember, we've looked at similar figures. And so that's what a dilation does, is it makes an image larger or smaller. So we're creating similar shapes. And so we're going to be talking a lot about scale factor, and we've mentioned that before. Scale factor is simply how many times larger or smaller that you will make the original figure. To find the scale factor, it's the new value over the original value. It is that ratio of new to original. And so if we know the original value, we can multiply it by the scale factor in order to get our new values. So a dilation with a scale factor of k, and that's what we're going to be using as our variable k. A dilation will be an enlargement, or the image will be larger than the original if my scale factor is greater than 1. So if k is greater than 1, then I'm making a bigger image. We are doing a reduction, or we're making the image smaller than the original if my scale factor is between 0 and 1. And my image will be the exact same as the original figure if I have a scale factor of 1. So that's making a duplicate. It is making a congruent image. So when the center of dilation in the coordinate plane is the origin, and remember the origin's the 0, 0, then each coordinate in the pre-image is multiplied by the scale factor k to find the coordinates of the new image. And so we are going to algebraically represent that as every ordered pair xy will go to the new image, or the new ordered pair kx, ky. And so again, k is going to be that scale factor, our multiplier. So let's start looking at some problems here. So we have triangle triangle ABC with vertices at 0, 0, and I'm just going to write those in. 0, 0, negative 1, 2, and at 3, 3. Okay, so there's my coordinates. We want to draw the triangle with a dilation with a scale factor of 2 on the same coordinate plane. So if I look at that algebraically, every xy must go to a new ordered pair with a scale factor of 2. That means 2x, 2y. So I'm going to take every ordered pair that I have, and so A we said was at 0, 0, B is at negative 1, 2, and C is at 3, 3. And so its new image, and the notation that we use for that is called A prime, B prime, C prime, and it looks just like this. We're going to multiply each of these coordinates by 2. So that means A prime is going to be at 0, 0, because 2 times 0 and 2 times 0 does not change. B prime is going to be at, well, let's see, negative 1 times 2 is negative 2, and 2 times 2 is 4. And then C prime is going to be at 3 times 2 is 6, and 3 times 2 is 6. So if I graph those, and I'm going to do it in red, and so A has not moved. A and A prime are still the same ordered pairs. And then negative 2, 4. Here's going to be B prime, and make sure when we're graphing these that we label, and then 6, 6. So here's C prime. And so now I'm just going to come up here and get my tool, and we're just going to connect these points. And so B prime to C prime back to A prime, and B prime down. Okay, so there is a dilation. It has created corresponding sides, but my angle measures are still congruent. Angle B and B prime are still congruent. Angle C and C prime are congruent, but the ratios of corresponding sides are proportional. Okay? All right, so let's look at another one. We're going to first graph some points. So we're going to graph 2, 6. So let's see, 2, and then 6, 1, 2, 3, 4, 5, 6. So there's the point 2, 6. And we're going to graph, and let's call this point A, B, and C. So here's point A. And C is at 6, 4, 1, 2, 3, 4, 5, 6, and that's negative 4. 1, 2, 3, 4. So here's B. And C is going to be at negative 4. 1, 2, 3, 4, negative 2. Here's C. And this time we're going to use a scale factor of 1/2. So that means every XY ordered pair is going to go to 1/2 X and 1/2 Y. So again, I'm going to go ahead and write these down. A, B, and C. And I need to multiply every coordinate by 1/2. And so remember, multiplying by 1/2 is the same as dividing by 2. So A is going to go to the new point A prime, and so half of 2 is 1, half of 6 is 3. And then B prime is going to be, let's see, half of 6 is 3, half of negative 4 is negative 2. And then C prime, half of negative 4 is negative 2, and half of negative 2 is negative 1. So now, let me go back because I haven't graphed the triangle that was created by those 3 points. So let's do that. Make sure you're using a straight edge when you're graphing and connecting points. It makes seeing your image in those dilations much clearer. All right, so now let's graphing our new ordered pairs. So A prime is now at 1, 3. So here's A prime. Again, make sure we label. B is at 3, negative 2. So there's B prime. And then C prime is at negative 2, negative 1. And again, we're going to connect our points. And so now, again, my angles are congruent, but my sides are still proportional. Okay? All right, so let's keep moving on. So now notice I have not given you a coordinate plane. We're not going to be graphing. Here we're just going to find out what those new coordinates would be. And so I'm being told I'm using a scale factor of 1/2. So again, if I use my algebraic notation, that means every XY pair must go to 1/2 of X and 1/2 of Y. So let's see, D is at 2, 5, so that means D prime needs to be half of each of those. So half of 2 is 1, half of 5 is 2.5. E prime is going to be at 4, 6, because that's half of 8 and 12. F prime is going to be at negative 3 and negative 7.5, again taking half. And then G prime, well, half of 0 is still 0, and then half of negative 7 is negative 3.5. And so I could graph, or I could have put negative 3.5 if I had stayed consistent there. And so there's my algebraic rule, and I can find those new ordered pairs without physically graphing. Okay? So now what we're going to do is we're going to sort of work backwards. Previously, I was given the scale factor. Now we're going to find out that scale factor. And so remember what we said earlier. The original times the scale factor will give us that new value. So this works on any dilation to find coordinates or missing side lengths. Okay? So to find the scale factor, we need to take the new measurement and divide it by the original. We're going to set up that ratio. So here we go. So again, it's important to notice what my notation is. And on this one, my little prime notation got cut off. So I have triangle ABC down here at the bottom, and it has been dilated to A prime, C prime, B prime. So just looking at this, I know it has enlarged. So I know my scale factor, and remember we're using K as scale factor, my scale factor has to be greater than 1. In order to enlarge, remember scale factor of 1 is a duplicate image, Scale factor greater than 1 makes it larger. So to figure out that scale factor, I can simply pick 2 points. So let's pick A. So A, which was at 2, 3, is now going to A prime, which is at 6, 9. So to find those scale factors, we have to take the new measurement and put it as a ratio. So remember, scale factor is going to be that ratio of new to original. So if I look at that ratio of x prime to x, then I can look at, let's see, my x values are 2 and 6, and so my new one was 6, so 6 over 2. And since we're maintaining that proportionality, then I must also have that same ratio of 9 to 3. And in both cases, 6 to 2 and 9 to 3 reduces to 3 to 1. So in this case, my scale factor is 3. So every xy basically went to 3x and 3y. So again, k is my scale factor. Okay? All right, so there was one. Now looking at this one, again, we want to find out what that scale factor is. And so it's important to figure out which one was the original. So here's the original. And here's the new, and we look for those prime notations. And so again, we can pick any 2 points. Again, I'm noticing that this has gotten much smaller, so this is a reduction. And so if I have a reduction, my scale factor has to be less than 1. It's got to be bigger than 0, but less than 1. So this time, let's pick point C. So point C is currently at 6, 3, and it has gone to the ordered pair C prime, which is at 2, 1. And so I need to find that scale factor. So again, my scale factor is the new over the original, and so I'm going to use my ordered pairs. Again, let's take x's. So I'm going to do 2 is to 6, so the new x to the original x, and that must be the same as the new y as the original y. Well, in both cases, these have a scale factor of 1/3. So again, scale factor is 1/3. So if I was to look at the algebraic rule, every xy ordered pair went to 1/3 x and 1/3 y. One more here. So again, triangle ABC has been dilated to triangle A prime, B prime, C prime. And so looking at this, I see that I have an enlargement. And so if I have an enlargement, my scale factor has to be greater than 1. So again, pick 2 ordered pairs. I think I'm going to choose A prime because those are easily readable from my coordinate grid. So A is currently at 4, 8. And it was dilated to A prime, which is at 8, 16. So again, this one's pretty easy to see what's happening. I'm multiplying A by 2, but again, let's just show that. So my scale factor K must be the new to the original. And so comparing x's, my A prime x value was 8, A value was 4, and on the y, I had a value of 16, and that corresponded to 8. And so that scale factor must be consistent, and so 8 to 4 and 16 to 8 reduces to 2 to 1 or 2. So my scale factor is simply 2. So every point is being doubled from what it originally was. And so if I look at that algebraic rule, every xy goes to 2x and 2y. Okay? So there we go. We've looked at dilating images on the coordinate plane using a scale factor and being able to write those algebraically. and then likewise, given a dilation, figuring out what scale factor was used. So I will see you guys later. Bye-bye.